Hello and welcome to 11.2. Today we're going to be talking about area still, but with trapezoids and kites. So area of trapezoids and kites. And then in parentheses we're going to talk about rhombi and squares again. So you see what I mean when we talk about kites. The trapezoids, as we know, a trapezoid has two sets of lines or opposite sides that are parallel. So the base 1 and base 2 are in fact parallel with each other. And just like all parallelograms and rectangles, this has a very similar formula to base times height of area of a parallelogram. Now, if you really want to think about this in terms of a rectangle, if we pretend, and I'll do this in pink, if we pretend that this is an isosceles trapezoid, meaning that the legs are congruent, we actually can create a rectangle. Because what we do is we are going to cut this piece out, we're going to rotate it around, and we could create a rectangle based off of that. And our rectangle would actually look like this. Now notice though, the base 2 actually gets cut a little bit. This part gets cut out. And then base 1 increases by that specific length. So the formula, what we do is we actually take base 1 and base 2, we add them together, and then we find the average between them, okay? Meaning, let me take this out. This is not necessarily an isosceles trapezoid. It could be any trapezoid. Area is equal to the average of the two bases. So 1/2 times base 1 plus base 2 multiplied with the height. And let's draw this dotted line again in black as opposed to pink. And there you have it. It's the area of a trapezoid. And that should make some logical sense because when we cut this out, we are subtracting it. We are subtracting that section. We are at the same time adding it to base 1. It becomes the average of the two bases. And that's why we have this part of the formula. So let's do a quick example of this. Let's pretend, so let's call this example 1. We have a trapezoid. This will not be an isosceles. Let's say this top part is 10. Let us draw an altitude. And let us say that this is 30 degrees. Let's say this part is 45 degrees. And we'll go ahead and say that we have 8 as this length. Can we then find the area? Sure, we absolutely could. But we actually need to solve for the entirety of base 2. So what we do is we're going to actually create another altitude here. And we're going to say that this part of it is equal to 10. And if you really, really want to think about this, a trapezoid is really 3 different shapes in one. We have a triangle, a rectangle, and then another triangle. And you could actually manipulate this formula so that it would turn into this equation. But we already have the equation. We don't have to do that. Let's just focus on the actual problem. So if the side is 30, we could then actually use our 30, 60, 90 info and say that this opposite, since this is 2b, we could say that b, this is our b side, is equal to 4. And then we could say that the 60 degree side is b root 3, which is 4 root 3 here. Since the altitude is equal to 4, that will directly translate to this altitude of 4. And we'll actually get this length here. Sorry, I probably should have put this like this. In a 45, 45, 90, legs are congruent, so this is also 4. And then if you remember, it's always goes x root 2 for the ratio of 45, 45, 90. So that means this is 4 root 2. Not that that's really important in this particular case, unless we were actually solving for the perimeter. What we are solving for is the area. So we're going to take some of this information. We're going to actually combine some terms together. Base 2 is equal to 4 root 3 plus 10 plus 4. There's only two things we could combine here. So we could say base 2 is equal to 14 plus 4 root 3. Now this is the exact base. If we actually use a calculator, we could say 14 plus 4 root 3 is equal to, 14 plus 4 root 3 is equal to approximately 20.93. And we could use this technically. It won't be exact, and I'll show you both answers. So let's do the actual area problem. Area, let's do the exact answer first. Area is equal to 1/2 base 1 plus base 2 times the height. And let's substitute everything in. A is equal to 1/2. Base 1 is 10. Base 2 is 14 plus 4 root 3. And then the height is 4 root 3, or 4. Combining some like terms, we get 24 plus 4 root 3. We have a 1/2 in front, and we have a 4 at the tail end. So if we want to, we could actually multiply the 1/2 and the 4 to make 2. So let's do this. Let's say this is 2 times 24 plus 4 root 3. Sorry, I should probably put area in each of these parts. And then the last part, we distribute this 2 in. So area is 48 plus 8 root 3 units squared. Now, if you use this 20.93, your answer will be the same. We could actually just, let's do this in the calculator real quick. 48 plus 8 root 3. And this is our area. Area is equal to 61.86 units squared. Okay? Now, if we used the 20.93 as our base 2, we could actually do this equation again. 1/2 times base 1, 10, plus base 2, 20.93, times the height of 4. And 10 plus 20.93 is 30.93. Multiply that by 4, divide that by 2, and we get 61.86. Now the difference is that this is the exact answer, and this is an approximation. 61.86, and I should have done that here. So you can see that you do get the same answer. You need to read this based off of what the question asks. If it wants an exact answer, this is your exact answer. We want an approximation, we have the approximation answer. Okay? Now, so that's the area of a trapezoid. Area of kites. Oh, I probably should have put trapezoid here, huh? So let's call this, let's put trapezoid. Trapezoid. Trapezoids. whether it's isosceles or non-isosceles. Okay, let's just leave it as trapezoids. So kites. Kites has its own formula, a very particular one. There's some characteristics that we do need to remember about kites, though, before we actually start breaking this down. And that is that there's two pairs of consecutive sides that are congruent, the top pair and the bottom pair. We also know that we should also remember that kites are symmetrical down the middle, meaning this diagonal part is congruent to that diagonal part, the left and the right side of that diagonal. And these two are not necessarily congruent. So don't be fooled if you're given a piece of the vertical diagonal, don't be tempted to put them as equal to each other. They are not necessarily equal to each other. Now, the way to do this, if you really want to think about this, is that this is just two different congruent triangles. We have a triangle on the left, triangle on the right, and you could actually just calculate this by taking the diagonals. The diagonals are actually our triangles. If you really look at it, we have a triangle here with a height. This is actual height. This is our base, and then 1/2 base times height. But we also have this other section to it. So our equation is kind of based off of that information. The area of a kite, or of kites, is equal to 1/2 times diagonal 1 times diagonal 2. Okay? And this actually goes for rhombi and squares as well. Now, we already talked about squares and rhombi, and that's if you were given the base and if you have the base and the height. But in this particular case, we're actually working with the diagonals. So if you're given the diagonals in a rhombus or a square, it's actually easier to use this formula. So let's talk about it. Or let's do an example. Let's do example 2. Let's say we actually have a kite. Oops, that's a terrible kite. Where, let's say this side is 10, this side is 6, and then this last side here is 17. One thing I did forget to mention is that we do have, I drew it earlier, is that we have right angles in the middle. Okay, so we have right angles in the middle, and we could actually solve for parts of this knowing that we have right triangles. So if you remember your Pythagorean triples, we should recognize that 6 is a leg, 10 is the hypotenuse, and we could actually solve for this last piece, which is going to be 8. This is a 6, 8, 10 triple. And as we said, if we have one part of the horizontal diagonal, we have the other, which is 8. So we could say diagonal 1 is equal to 16. Now, remember when I said that the top part of the vertical diagonal is not congruent to the bottom part of the vertical diagonal? And that's actually going to be the case here, because if you recognize, we have another right triangle. And in this particular case, it is another Pythagorean triple. It is an 8, 15, 17 triangle. So that makes diagonal 2 equal to 21, because it's 6 plus 15. And then here, all we do is just plug this into our equation. Area is equal to 1/2 diagonal 1 times diagonal 2. Or in this case, area is equal to 1/2 16 times 21. So just plug this into our calculator, or if you're using mental math, awesome. Let's say 8 times 21, and we get 168 units squared. Cool. Now, I want to do one more example with you. And I don't know why I put example squared. That's going to bother me. Example 2. And let's do one more example with a square. Example 3. Now, if we have a square, we know that the square has 4 right angles. And what if we're actually given the diagonals? Right? One thing we should remember too is that the diagonals are actually perpendicular. So you could use that information. But let's say one of the diagonals is equal to 5, right? Well, the full diagonal, that is. So let's just highlight this. That diagonal is equal to 5. Then, since we know that diagonal is equal to 5, diagonals in a square are congruent to each other, so that this diagonal is also 5, and we could actually calculate this really, really quickly. Area, let's do this in red. Area is equal to 1/2 d1 times d2, and in this case it's just area, is equal to 1/2 5 times 5. Okay, so then area is equal to 12.5. Now we could do this units squared. Units squared. We could also do this technically if we wanted to solve for the let's do this, let's erase this. What if we want to solve for the base and the height? Base and height. We know that this is a 45, 45, 90. So we could actually solve for the base and the height. Since the diagonal is 5, it breaks it apart into 2.5 and 2.5. Probably should have used a better number than this, but we can still do this. The legs are 2.5 and 2.5, which means this is our, in this particular triangle, we have the right angle is the base, or the hypotenuse is the base, right? And it follows the pattern 2.5 root 2. We could do this in our calculator really quickly, or we could also just, we could just leave it like this. So that is what one of the sides is equal to. And since that's a side for one of the sides in the square, it's equal to all of the sides of the square. 2.5 squared, or 2.5 root 2. And as we know, if we're using base and height or sides in a square, area can also be side squared. So area is equal to 2.5 root 2 squared. 2.5 root squared, and we could do this in our calculator. 2.5, oops, let's start with the parentheses. 2.5 root 2, make sure you get out of the radical, close the parentheses, and then you square it. You get 25 over 2, which is 12.5 units squared. So as you see, a lot more work to do that way. If you're given the diagonals, use the diagonal equation. If you're given the sides, use the base and height for the side equation for a square. Okay? All right. If you do have any questions, please let me know, and I'll see you in the next one. Bye.